Thank you all for joining today. Today, I'd like you to walk through the Manufacturing Impact Analysis Engine, or MIAE, the architecture, the core capabilities I have built, and the future enhancements that will evolve into an intelligent manufacturing decision platform. Modern manufacturing organizations generate enormous amount of data across engineering, procurement, inventory, production, and sales. While this information is available, it often exists in separate systems, making it difficult to understand the downstream impact of a change or the dependencies between different business entities. With MIAE, our goal is to address this challenge by creating a connected manufacturing knowledge graph that brings together products, BOMs, components or items, suppliers, inventory, work orders, sales orders, and customers into a single unified model. So as you can see on the slide, let's first understand the underlying manufacturing knowledge graph. So each box in this diagram represents a business entity from the manufacturing domain, and each arrow represents a business relationship. For example, a customer places a sales order. The sales order orders a product, and the product is associated with a specific BOM revision. The BOM revision defines the components or items which are required to manufacture the product. Each component is sourced from one or more suppliers. Finally, a work order is created to build that specific BOM revision. So here the key message is, instead of storing these entities in isolated tables, we model them as connected graph. This creates a single source of truth for product structure, manufacturing execution, procurement, and customer demand. Because everything is connected, we can answer business questions simply by traversing the graph. Okay, let's go to the next slide. The component diagram. Okay, so this diagram shows the logical components that make up the Graph Traversal API. Each component has a single responsibility, making the solution modular and easy to maintain. So the topmost layer is the REST controller. So REST controller is the entry point into the application that receives the client request, perform basic request validation, and delegates processing into the service layer. Now, Graph Traversal service that orchestrate the complete traversal workflow, that validates business inputs, coordinate repository calls, and transform graph data into the API response. Graph Traversal repository that is responsible for interacting with Neo4j. It executes the shortest path query and return native graph paths. That hides all the cipher query implementation from the rest of the application. Neo4j database stores the manufacturing knowledge graph that allows complex relationship queries to execute efficiently without custom traversal logic in Java. Response mapper that converts Neo4j graph objects into the API response model that determines the traversal direction, calculates hop counts, and build the client-friendly response. Response DTOs are the final output in the technology-independent response contract. Clients receive only business entities and relationship without any Neo4j specific implementation details. The request flow is a client submits a graph traversal request. The controller forwards the request to a service. The service invokes the repository. Repository executes the graph traversal in Neo4j. Neo4j returns the shortest path. The service maps the graph into the response DTO. Finally, the controller returns the response to the client. So impact analysis APIs is the first capabilities built on the top of the knowledge graph. These API answers business impact questions. For example, which customers are affected, which work orders are impacted, which suppliers are involved, how much revenue is at risk. This API aggregates information from across the graph and return actionable business insights. This significantly reduces manual analysis during engineering changes and supply chain disruptions. For example, revision impact. The purpose of revision impact is to evaluate the downstream business and operational impact of introducing, modifying, or retiring a product revision. Component impact, purpose of that evaluates the business impact of a component across the manufacturing ecosystem. Supplier impact, purpose of that is to evaluate the business and operational risk associated with a supplier. The analysis identified supplied components, dependent products, and manufacturing activities, helping organization access supply chain disruptions and supplier-related risks. So this is the interaction diagram we are looking at, which I have just explained. So this is the interaction diagram of the ingestion APIs. And this is the interaction diagram of the impact APIs. Okay, now let's talk about the manufacturing impact Copilot. So far we have seen how manufacturing data is represented as a connected knowledge graph. The next step is making this graph easy to query without requiring user to understand APIs or the graph databases. This is where manufacturing impact Copilot comes in. Manufacturing impact Copilot provides a natural language interface over the manufacturing knowledge graph. Instead of navigating multiple ERP screens or writing complex queries, users simply ask questions in plain English. Example questions: which customers are impacted if a particular component becomes obsolete? Which supplier provides component for the particular work order? Show me how the work order is connected to supplier Siemens Energy. Which product use this particular component? What is the impact of changing a particular BOM revision? So how that works is the Copilot first understands the user's intent. It identifies the entities mentioned in the question. Based on the question type, selects the appropriate backend capability. For business impact question, the Copilot invokes the impact analysis APIs. For future releases, for connectivity questions, the Copilot will invoke the graph traversal API. Also, Copilot can combine the result into the natural language response with supporting evidence. So every answer returned is backed by the manufacturing knowledge graph. So this makes the Copilot transparent and trustworthy for engineering and supply chain decision, because users can not only see the answers, but also the dependency path and evidence that explains how the entities are connected and affected. So business benefits are that accelerates the root cause analysis, reduces manual investigation across multiple ERP modules, improves engineering change impact analysis, support procurement and supply chain decision making, make knowledge accessible to both technical and business users. We'll discuss about the future releases or the future roadmap. So far now, the current implementation establishes a connected manufacturing knowledge graph and impact analysis foundation. Looking ahead, there are several opportunities to extend this platform with additional intelligence capabilities. So first, asset impact intelligence. So today our impact analysis focus on product, component, suppliers, and customer demands. The next step is extended that intelligence into the manufacturing assets. So basically what is this? From engineering and supply chain impact analysis to manufacturing execution impact analysis. That introduce entities like work order operations, work centers, and equipments into the existing manufacturing knowledge graph. enabling MIAE to determine how manufacturing assets influence work orders, products, sales orders, customers, and revenue. So this enables organization to understand, for example, how equipment health affects production. If a critical machine becomes available, the platform can immediately identify the affected work orders, products, deliveries, and customers. So provide dependency analysis between manufacturing asset and business entities. Okay, now about the second graph traversal API. So while impact analysis answer business impact questions, graph traversal answers connectivity questions. For example, if I start from a work order, I can transverse upstream to discover which supplier provides required component, or I can traverse downstream to identify which customer ultimately ordered the product being manufactured. So if we look at the traversal summary, here the source is the work order and target is the customer. So that explains the technical aspects like short paths and hop counts. So here the work order builds the BOM revision. Product has a revision, so that has traversed in the reverse to establish the relationship. Sales order has ordered the product, so product is tied to a sales order. And then which customer ordered the sales has placed the sales order. So that gives the dependency. These capabilities allow engineers, planners, and supply chain teams to explain dependencies. Users can discover exactly how two manufacturing entities are connected. For example, how this work order connected to the customer. Which supplier provides the component used in a particular work order. Or how the work order is tied to a supplier. Okay, closing. Our long-term vision is to evolve from a connected manufacturing graph into an intelligent manufacturer decision platform. One that not only store relationship, but also explain dependencies, predict impacts, and help engineers make faster data-driven decisions. Thank you. That's in the today video.